let's talk about torque converters today. So I've got a torque converter. It's actually sitting on a pump, and the turbine shaft. This would be like the front clutch assembly in a 4R70 W transmission. So let's just start. We're gonna take the clutch apart. It's been cut at its weld, so I'm just gonna take pieces off of it as we go along. So here is one half of the torque converter housing. And so this has the studs on it that would go through the flex plate on the back of the transmission. Automatic transmissions have a flex plate because it needs to be flexible, because the torque converter creates basically 90% of the heat inside of a transmission or transaxle because of the slippage that goes along inside of it. And so a torque converter can swell up a fair amount. Like when we are torque loading an engine at stop with a foot on the brake, a foot on the accelerator, there are pockets of transmission fluid that can reach 1200 degrees plus. Sometimes I've even been told that they can get up to 2000 degrees Fahrenheit, and these like little micro burst bubbles that happen inside of it. So like pretty crazy. So the torque converter can heat up, swell up, and so that's why we have to have a flex plate on our automatic transmission vehicles instead of a flywheel. So our studs for mounting. There's a hub on the end of it. Sometimes that'll sit into the back of the crankshaft, like on hybrid electric vehicles it does, but on most regular automatic transmissions it does not. So we'll get that out of the way. The next thing, I think let's angle this so you can see it, is you see the friction material that's built onto this side of the clutch cover. So, torque converter housing. So this is where my torque converter clutch is going to make connection, okay? And that torque converter clutch is right here. So you can see it's got these damper springs built into it. These are there to take out the pulses that happen when we have combustion. So let's say we have a 6-cylinder engine. As this rotates, I'm going to get 3 power pulses per revolution, because half of them are going to fire each revolution. So these are there so that as I get that pulse and the torque converter, and the crankshaft speeds up relative to the torque converter, I don't get a surging inside of the transmission that would be felt by the driver. The springs are supposed to kind of absorb a little of that, so they let this middle hub move. But what this torque converter clutch does is, on one end, right here, it is splined to the back casing of the torque converter. On the other side, it grabs the front half of the casing of the torque converter. And normally what happens in this torque converter is the back and the front are not connected to one another whatsoever. When the crankshaft spins, it spins the back, and this is like a fan for transmission fluid, so the back spins, creates this motion of fluid, and then my turbine, or actually my impeller, which is this piece right here. Let's see if I can actually get it to come out. So here's my turbine. This attaches to the turbine shaft, which is the input shaft of the transmission. So what happens is, might as well just take it all the way apart at this point. This piece, you can see on the back, you see like the crazy pattern? That's all of these blades being welded onto the casing itself. And because this and this are usually welded together, this is bolted to the flywheel, that's bolted to the crankshaft, so when the engine is spinning, the casing of the torque converter is spinning. This piece on the outside, not this in the middle, but on the outside, you can see the fan blades there, right here. This spins, creates motion, rotational motion of fluid. That is caught by my turbine. So this is my impeller. This is what makes the motion. then my turbine catches that motion. You see how it has similar shaped fan blades on it. It catches the motion, and then it is splined onto the input shaft of the transmission. I got it on backwards. This is splined onto the input shaft of the transmission, and that actually creates the motion there. So 2 fans. Let's think of it like we've got 1 fan that's plugged into power, 1 fan sitting in front of it that's not plugged into power. If I create air motion with this one, it's going to make the other fan blade spin. And we're doing the same thing but with fluid. Now on these, there's some crazy ports. You see how we've got this deflector ring on it? This is because what's happening is this is a centrifugal force pump. So as it spins, the weight of the fluid is pushed outward like a centrifuge. And so what is happening on these is I've got my impeller, which is attached to the engine. So this spins, and all the fluid in the middle is forced outward. And so it's forced out through these channels around the outside of the torque converter. That is then caught by the turbine right here, and it's caught on that outer ring. And then that's forced back towards the center, which then feeds my impeller once again. You see how this is able to kind of revolve and loop the fluid from inside to outside and from outside to inside. And then it does it again and again and again and again and again. All right? So this is part of the torque converter idea. They call it a torque converter because we can actually multiply torque at low speeds. If the engine is spinning faster than the transmission, then I get torque multiplication. And that is created 100% by this little devil right here. This is my stator. So this is a one-way clutch. One direction it's allowed to rotate, and the other direction it locks up. My finger's there, so it rotates, locks up. So when the engine's spinning faster than the transmission, this is in its lock state. And these fins redirect the fluid to help the impeller spin even faster. It's like if you took a pinwheel and blew on it. This is blowing in the correct direction to keep that pinwheel spinning. So very important. At low vehicle speed but high engine RPM, my impeller is spinning faster than my turbine. And because of that, this is in its locked state, and this helps give me torque multiplication. So an automatic transmission is going to be faster off the line than a manual because I have one more opportunity to multiply the torque, to give my engine as much the engine doesn't increase horsepower, but to increase the torque provided by the horsepower of the engine to the transmission, the torque converter can do that. And they make race torque converters. The smaller the torque converter is, the more multiplication we get. The larger the torque converter is, like the actual housing, the larger it is, the more efficient it is. Less multiplication, but like at highway speeds, we're not going to get that much of a power loss, and so it's going, because it holds so much fluid, so it's going to give us better fuel economy. We've seen this in Fords because Ford powertrains have been in like U-Hauls and moving trucks, U-Hauls aren't moving trucks, but U-Hauls and RVs and stuff like that, and they put a smaller torque converter in an RV than they do in a pickup truck. And the reason for that is the RV is heavier, so we need more torque multiplication. Smaller torque converter gives us that multiplication. Alright, so I fed you a ton of information, but let's stack this all up on the pump and see how this all works. On my pump itself, I've got my turbine shaft. This is the input shaft, this piece on top, and then I have my stator. The stator, just like all stators, is stationary. That's what a stator means. It's a stationary component. So this is what my one-way clutch is going to spline onto. So here we go. Alright, and so this is, again, what redirects my fluid flow. And you can see spins freely in one direction and the other direction. It's all locked up. Alright, so let's start stacking. I will begin with my impeller, which is the back side of the case. And you can see that I've got my hub right here, and it's got two flat spots on it. That's what's going to engage with the pump. And we're going to look at that in 1 second. But so this goes on, and I have to line it up with my pump, which it looks like it did quite nicely. So that's usually the first clunk you get when you go to install a torque converter. Then I will put my stator in. So that's all installed. Next will be my turbine. And this is directly going to spline to the input shaft of the transmission. So this is what literally drives the input shaft of the transmission. Fluid from the motion that's created by my impeller forces this to move, and this is what makes it so my transmission will move down the road, and what also allows me to come to a stop without having to shift out of gear. So there that goes. Torque converter clutch, which would lock the front half of my case to the back half of my case, causing all of this to be negligible. And so if my crankshaft is spinning, then my flywheel is spinning, my turbine is spinning. This is locked to the same case that the turbine is welded to, and so I don't have any slippage anymore. This only comes on when I'm moving at a decent speed. Nowadays it's like 30, 35 miles per hour plus without much of an APP, without any braking going on. Creates a fair amount of load. So this goes on top. This is just that front part of the case. And there is my torque converter. Now, what I want to take a look at, take this whole piece off, is my actual pump assembly. So this would be in the top of the case. Take the bolts out, pump bolts out. And here's my actual pump body. My turbine shaft is the input, and this would have my forward clutch in it, so you can see the clutch basket there. Alright. Another thing to look at is my actual stator. Never see it so we can have some light. So here's my stator. This is non-mobile. This is pressed in place. It's fixed. It's not going to go anywhere. So now what I want to do is I'm going to take my pump apart. And usually I do that on top of the torque converter. So I could probably get away with flipping this whole thing over without making a huge calamity. So torque converter is flipped over. You can see a couple of balance weights on it, and some of the older torque converters will have a drain plug built into it as well. So that would have to have been put in, drilled and installed before they balanced it, for obvious reasons. But here I'm going to put my pump on my torque converter, and the reason I like to disassemble and assemble my pump like this is because of the way that the gears inside of the pump set. So let's take this apart, pardon the noise. So I'll take the bolts out. And now I'm going to take, so I have my pump body, I'm going to take the actual pump itself out. Alright, so you can see, got some fluid tension on there. Here's my gear for my gerotor style pump. I'll pick this up so you can see it. Get it splined up. So here is my gerotor style pump. The torque converter has two flat spots. It just drives the pump like so. And if we take this exterior gear and internal gear out, you can actually see the intake and exhaust ports. So as this spins, it squishes fluid pressure through the exhaust, takes it in through the intake. Now, why, you say, do I like to build this on top of the pump? One reason is it fits pretty nicely because the snout or hub of the torque converter just sets right into that pump itself. That's why I like to build it on top of the torque converter, not the pump. The external gear will go in without much fight. If I can get it locked a little bit, so this will just slop right in there. Alright, but then the real issue happens is when I go to put my external gear, external toothed gear, so if you look at this, I can actually make it so it's not really centered with the hole. You see how it just like walks around all over the place? So I could bolt the two halves back together again, and this could be offset. And it'll make it really, really hard for my torque converter to spline up. I'd have to like wiggle it around a whole lot. If I build it on top of the torque converter locates this external tooth gear, but like the inner of the two gears. It locates that perfectly so that it will just line right up again. Now, one thing to note on this gear is on one side there is a beveled edge, and you can see it pretty nicely there on the inside. See the bevel? On the other side, it is just completely 90-degree angle. You can put this in either way, and it won't destroy the pump. The issue is you want that bevel, if I can find it in the light again real nice, you want that bevel right there to be facing the torque converter because it acts like a funnel and helps the torque converter grab those flats more easily. You can put it in there the wrong way, and if you ever get the torque converter to mesh with it, then you're a better human than I am. It's very, very difficult. So they build these this way on purpose to help with installation of components. But if you take it apart and you're like, oh gosh, I don't remember which way it went, just think bevel goes towards the torque converter, acts like a funnel, helping to accept it. So I'll make that happen. I'll install this on the torque converter, and I have to get the flats to line up. Go. So now everything's all lined up. You can see that the hub of the torque converter has made it so that my gear is in the right place all the time. So now I can go about installing the stator back into my pump body. And this has offset bolt holes in it. See how the pattern's not very consistent there. So then I'll just have to spin it around in a circle for a couple moments until I figure out how all of it's supposed to go together. Right, and so then the pump can come out, and you can tell how, especially with the torque converter seal in there, how it'd be really hard to reposition that gear to make everything line up. So this is really just like a tip from an old transmission tech that I learned that makes life easier. It's the small things that count, right? So then this in front, this will set down onto a turbine shaft and front clutch, and the distance between here, so you can make it light here, and where it's a setting, this is where the selective in-play shim would go. Got it on there, but that was loud. So then at this point I would just take my torque converter up and lift it on, but mine's multiple pieces, so first things first, the 3 clunks that happen when we spline a torque converter onto a pump is first, the actual hub, there goes the hub of the torque converter, has to mesh with the gerotor gear inside the pump. The next clunk we'll get is when the stator splines on. And then the last clunk is when the turbine meshes with the turbine shaft, input shaft. And then my outer case, the one that would go towards the flex plate, that doesn't have to spline with anything because it's welded to the turbine, or the impeller side of the torque converter. And it's just that simple.